Hello, everyone. In last class, I promised I am going to record a video to show you how to use yarGen. Right now, you will see the yarGen actually is the Yara rule generator prepared by Foreign Roof, date back in the year of 2020. So basically, what is yarGen? It means the principle of creation of Yara rule automatically from checking the strings contained inside the malware while removing all strings that also appear in goodware files. What is the string of goodware files? For example, in all Word document, Microsoft Office Suite, and or maybe PDF or some other solution, they are frequently used by enterprises environment. Foreign Roof try to take out all the string that contain in this kind of goodware. And then when you using the yarGen, which is a Python tool on Python 3, it will go to check the database of these strings contained in these goodware files. And then eliminate all this. And then by elimination, the only abnormal or suspicious string character contained in the file to be inspected will provide as a good basis to be used in the Yara rule. So now let me go to the one of the environment we can run the yarGen. Okay, right now I start up my Remix machine, which is a Ubuntu version malware analysis virtual machine that created by Sense Institution. And I have already shared out the Remix machine version 7 in our Dropbox. You can download if you want to play around with the yarGen. Why I need to use Ubuntu version? Because the Python version on virtual environment of the Windows system, they are, even though they are quite new, they are also Python 3, but one of the required boundary, can't remember, cannot be installed in the virtual environment of Windows 10 that can match with the basic requirement with yarGen. So let me start the yarGen. Before that, I go to the GitHub from download the yarGen, and I also provide some sample right here. For example, you see one samples right here, and also this sample, actually, I have provide a password infected to be kept under the folder called underscore binary. The output folder is a must to hold the generated Yara rule. Right now, you will see I have one sample, only one sample, called select my parent.exe. So how to run the yarGen or yarGen program? I need to use the Python 3, yarGen, Python. Let me go to HC if the help key. What switch I can use? Basically, you just need to specify a couple of things. For example, the binary, where's the location of the malware to be analyzed, that is M. And then second one is the output. Where's the output rule? You need to specify the output rules path. That means you need to specify the location in the folder or directory, as well as the rules name. So I usually put only one sample inside the sample folder because I don't want the output will be mixed with other. By default, if you can put a lot of sample inside with one sample folder, and then you try to execute the yarGen, and it will generate one Yara rule that combined all samples that is identified by the yarGen signature, and then create the Yara rule for you. So right now, I just use this M switch and the output switch. Other than that, I do have a practice try to using, for example, my name inside. So let me right now run the yarGen with Python 3. I specify with the M option, referring to the sample folder, and local folder. Oops. Don't know why it can't, but let me check with the sample folder. It works. So Python 3 yarGen, and then M samples, and then or that is order, then KD, and then output with the location of sample yar, and I give it a name. For example, I use 7005A test yar. So right now you see it tried to identify the sample, and then checking different database, goodware sample by eliminating any string file in this database, and then compare with the string character that have been able to identify in the sample that provide under the folder called underscore sample. Then after a while, okay, after a while, after I pause the video capture, my program runs complete, and then let me check what is contained inside the sample folder. Sample, yeah. Oops. Okay, I have 7905A right here. If I want to check with these folders, this file name, and then 7905, you will see that a Yara rule automatically created by a name with the date, identify location, that is referenced from the GitHub of the yarGen. The rule set the name is select my parent, which is the sample contained inside right here. Metadata will show the default information by referencing to yarGen and the file name, and my author name with the -a, and the time of today I create this Yara rule. And the hash one is the automatically calculated, I think that is #256 from the sample called the select my parent.exe. And the string provided right here, you will see inside this public domain, Data Steven, and then select my parent by referencing a location. You have some rich information in this sample. There are totally 20 of these samples, and the conditions specified by the yarGen default 8 of them. That is the sample that I just create. Now let me show you some other sample that I create before that. Actually, there is two samples I want to show you. One is my one of the tool that I create, I have identified in the red team exercise. The file name is called patch AMSI and ETW. Another result is from one of the famous GitHub related with the AMSI and ETW unhooking solution. So let me show you these two samples. Let me show you the first one that is related with the sample that I dig out from the GitHub. The file name is called sharp unhooker. And you will see some description right here, the similar things that I showed you before. There are also 20 of the string characters can be dig out from this sample, the sample file name, and then copy the shell code. There is some command right there, and also some and 64 encoded data. Okay, yarGen also whenever yarGen running, if there are some base 64 encoded string have been be found in the sample, and you will see that yarGen will take it out as the content. For example, the content is ETW successfully patched it, AMSI successfully patched it, and then it will find the AMSI DLL tag, and then some other information you will find. Remember some of the famous strings that have been identified right here, and you also check the field to check the IAT import address table. Now we go to the another sample that I can find in the real life. That is called patch AMSI and ETW. Okay, so I create this Yara in March 18, and you will find that, okay, right now we have another path saying that this is the red team from AD resources location. It shows some debug symbol file in this sample, and then the file name. You also find the sharp unhook DLL inside the sample. So this is only a version of the sharp unhooker that I identified from the yarGen dig out from the string character. And you will see it will maybe doing some more things that called shellcode D3 executed, and also using the same base 64. And then you can find some other information apart from the previous sample. So I am thinking by using yarGen, maybe you can identify once you generated these yarGen come out, if you put a similar, you believe they are similar sample, you may be able to identify whether they are their origin of a particular sample you have collected, and you want to use Yara as a tool to compare the string differences between these two samples. Okay, this is the demonstration of yarGen that you can make use. It's quite straightforward, and just remember that you need to go to GitHub to download it, and then install the relevant related requirement binary. I mean, not the binary, the Python module, so that you can run on Ubuntu environment.